Somewhere out there, right now, there is a galaxy so enormous it should not exist. Not according to our equations, not according to our models, not according to anything we thought we understood about how the universe works. James Webb found it. And what it implies about the true scale of reality is so staggering that some of the world's top cosmologists went quiet when they saw the data. We are going to show you exactly what they found. But here is the thing. The full picture, the real reveal, the number that will genuinely change how you see existence itself, that comes at the very end of this video. And trust me, you need to stay for it. Before we get there, quick question. Where in the world are you watching this right now? Drop it in the comments. Because people from over 80 countries watch these videos, and that fact alone says something powerful about how curious humans are about what lies beyond us. Now, let's go back to the beginning. For most of human history, the universe felt manageable. Ancient astronomers looked up and saw a ceiling of stars, fixed and familiar. Even after we learned the stars were suns, impossibly far away, the universe still felt like something we could eventually wrap our minds around. Then, telescopes got better, and the universe got bigger. By the late 20th century, astronomers had landed on a number, a few 100 billion galaxies spread across a sphere roughly 93 billion light-years wide. The number was absurd by any human standard, but it was a number. It had edges. It had a shape. Scientists could work with it. Then the James Webb Space Telescope launched, and the first thing it did was point at nothing. A patch of sky so dark, so empty, that most people would walk past it without a second thought. Webb stared at that darkness for hundreds of hours, collecting light so ancient it had been traveling since before our solar system existed. What came back broke the model. Now, to understand why what Webb found matters so deeply, you need to understand one thing first. When you look into space, you are not looking across distance, you are looking back through time. Light moves fast, roughly 186,000 miles per second, but the universe is so vast that even at that speed, light takes time to arrive. When you look at the moon, you see it as it was 1 second ago, the sun 8 minutes ago, the nearest star 4 years in the past. And when Webb looks at the most distant objects it can detect, it is seeing light that left its source over 13 billion years ago. The sky is not a live picture of reality, it is a fossil record. Every photon is a message from a different moment in history. And Webb was built to read the oldest messages of all. Its mirror stretches over 21 feet across, coated in gold because gold reflects the kind of light Webb hunts, infrared, the stretched-out, cooled-down remnant of ancient starlight that has been traveling so long the universe itself has changed around it. Webb does not orbit Earth. It sits nearly 1 million miles away, cold and still, waiting for photons that arrive one at a time, faint signals from the edge of what is knowable. And what those signals revealed was not a quiet, dim, barely formed early universe. It was chaos. Brilliant, impossible, defiant chaos. The early universe was supposed to be simple. After the Big Bang, space expanded, temperatures dropped, and matter spread outward in almost perfect uniformity. Gravity would slowly, patiently, over billions of years, pull that matter into clouds, then stars, then galaxies. It was supposed to take time, a lot of time. Models predicted that the first galaxies would be small and fragile, dim collections of early stars, tentative and sparse, barely clinging to existence in a cosmos still finding its shape. Webb looked for those dim, fragile galaxies. It did not find them. Instead, it found fully formed, blazingly bright, extraordinarily massive galaxies already in place when the universe was less than 300 million years old, less than 3% of its current age. On the scale of a human lifetime, that is like finding a fully built skyscraper on day one of a construction project that was supposed to take 30 years.
These galaxies were not just there, they were active, producing stars at rates that rivaled much later, much older galaxies. Some of them contained chemical signatures of carbon and oxygen, elements that only exist because earlier generations of stars had already been born, lived full lives, and died. That means before these galaxies even existed, something else had already come before them. The universe had already completed cycles of creation and destruction that our models said were impossible that early. Astronomers called these objects universe breakers, not as a compliment, as a warning, as an admission that something in our understanding had cracked. And the black holes were worse. At the centers of these early galaxies, Webb found supermassive black holes already weighing billions of times the mass of our Sun. Building a black hole that large normally requires feeding it material for billions of years. The early universe had not had billions of years. It had had hundreds of millions. And yet there they were, fully grown, already dominant. Our best physics had no clean answer. Maybe the first stars were thousands of times larger than any star today. Maybe gas clouds collapsed directly into black holes without forming stars at all. Maybe the early universe was so dense that black holes merged faster than any simulation predicted. None of these explanations have been confirmed, but here is what is undeniable. The universe did not ease into complexity, it sprinted toward it. And then Webb did something even more unsettling. It counted. Previous estimates placed the number of galaxies in the observable universe at a few hundred billion. That number came from the deepest images Hubble could produce, fields so small you could cover them with a grain of sand held at arm's length. Webb looked at a region of sky only slightly larger than 3 full moons placed side by side. It collected over 10,000 individual exposures, and in that single frame, it found nearly 800,000 distinct galaxies. When that number was scaled up across the entire observable sky, the total count did not stay at a few hundred billion. It jumped to trillions. Not 2 or 3 trillion, potentially 10 times more galaxies than we thought. Each one containing millions, billions, sometimes trillions of stars. Many of those stars almost certainly hosting planets. Many of those planets almost certainly hosting chemistry far more complex than we have explored. The universe is not a sparse scattering of islands in the dark. It is dense, it is layered, it is almost unimaginably full. And we have only been looking at a fraction of it. Because here is the part most people have never fully reckoned with. The observable universe is not the universe. Space does not stop at the edge of what we can see. Galaxies continue beyond our horizon. Entire cosmic histories unfold in regions that no signal from Earth will ever reach, and no signal from those regions will ever reach us. Not because our telescopes are too weak, because the universe itself is expanding too fast. Space between us and those distant regions grows faster than light can cross it. We live inside a bubble of knowable reality, and most of what exists is permanently, irrevocably outside it. But here is what nobody tells you about that bubble. We may have been measuring it wrong.
This is the part we promised you at the beginning, the number that changes everything. Cosmologists have 2 different ways of measuring how fast the universe is expanding. One looks at the ancient afterglow of the Big Bang, the faint radiation left over from when the universe was only 380,000 years old. That method gives an expansion rate of about 67 kilometers per second per unit of cosmic distance. The second method is more direct. It measures the distances to nearby galaxies using stellar explosions and variable stars, then compares those distances to how fast those galaxies are receding. That method gives a different number, around 73 kilometers per second per unit of distance. Those 2 numbers do not agree. That gap has a name, the Hubble tension, and it is one of the most serious unsolved problems in all of modern science. When James Webb launched, the hope was that it would resolve this. Its measurements were sharper and more precise than anything before it. It would clean up the data and the numbers would finally converge. They did not converge.
Webb confirmed the higher expansion rate. The gap did not close, it sharpened. And what that means is deeply uncomfortable. Either our measurements of the ancient universe are wrong, or our measurements of the nearby universe are wrong, or neither is wrong, and instead, something is missing from the fundamental equations we use to describe reality. Some researchers now suspect dark energy, the invisible force accelerating cosmic expansion, may not be constant. It may be changing, strengthening. And if that is true, then the future of the universe looks very different from what we assumed. In the standard picture, dark energy stays constant and expansion accelerates gently forever. Distant galaxies slowly drift beyond our horizon. The universe empties out over trillions of years. But if dark energy grows stronger over time, the end is faster and far more violent. Expansion would eventually overwhelm gravity not just between galaxies, but within them. Then within solar systems, then within planets, then within atoms themselves. In a scenario called the Big Rip, the universe does not fade, it tears itself apart from the inside out. Current data does not say that is what will happen, but current data cannot rule it out. And this is the full weight of what James Webb has placed in front of us. We looked into the darkness expecting to confirm what we already believed. We expected a quiet early universe, a manageable galaxy count, a clean expansion rate, a tidy story. Instead, we got galaxies that should not exist, black holes that built themselves too fast, a galaxy count 10 times higher than predicted, an expansion rate that refuses to make sense, and a universe so much larger than the portion we can see that the word universe itself may no longer mean what we think it means. Webb did not answer the biggest questions. It revealed that the biggest questions are far bigger than we ever asked. So next time you step outside on a clear night and look up, know this: every star you see is part of one galaxy among trillions, each surrounded by a darkness that is not empty, but full of things we cannot reach, cannot see, and may never understand. The universe is not just larger than you imagine, it is larger than you are capable of imagining. And somehow, against extraordinary odds, you are inside it, looking out, asking why. If that hit differently than you expected, leave a comment below. And if you want to keep going deeper into what Webb is still finding, the next video is already waiting for you.